Okay, good afternoon, everybody. I see people are still joining, so we'll just wait a second or two to before we start. Today, it almost looks like the agenda was planned, although I deny anything along those lines entirely, because we're following on from a session on object storage basics and introduction, and now we have a deep dive into using the TS7700 as an object store. It's purely serendipity, so let's take advantage of it, and I'll hand over to Laurie, who'll go through the presentation. Questions at the end, please, and put them in the chat window beforehand. Laurie, over to you. Thank you very much.
You bet. All right. Thank you very much. Thanks for attending. I'm Laurie Goodall, and I work at IBM in Tucson, Arizona. It's actually 8:30 in the morning. I am a 7700 development architect, and one of the pieces that I have been working on actually for a few years is the advanced object store for the 7700. And we are going to do a deep dive. Last week, we just kind of had an overview with the DFSMS and DS8000 team. And this one, we want to kind of go deeper into the 7700 new function that we have coming out later this year. This is session 7AW. Some information about the charity raffle, so check that out. So I'm going to just do a quick overview of TCTs for those that are maybe new to the topic. And then I'm going to give you just some quick information about DS8000 multi-cloud, which delivered earlier this year. And then we're going to get into the advanced object store. This is a pretty lengthy slide deck. Wanted to include it so you had it a PDF. We're not going to get through every slide, but I just wanted to touch on the main pieces. So what is this transparent cloud tiering thing, and why would you want it? Is really what the first few slides are talking about. So the image on the left side is like an overview of how tape storage worked before, when you have a ZOS, a primary disk, and then some form of backend storage like a physical tape library or a logical virtual tape library. Whenever that data needs to be archived, backed up, or moved to a secondary storage, all that data has to be read back off of primary disk into your ZOS system, and then out the FICON, a separate set of FICON through virtual to a virtual or physical tape system like the 7700. So there's a lot of data movement that happens in ZOS, and that data movement takes a huge amount of resources on that mainframe. With transparent cloud tiering, we move away from having the ZOS handle that data movement. And since the primary disk has to move or has to read that data off of the disk anyways, and then move it somewhere, you know, in the old way, being back to ZOS, we have transitioned or evolved into just having that primary disk storage move it to your object storage for you, so that you no longer go through the ZOS and eat up those resources by doing that data movement. So it's just this evolution on how we move data. So there are three parts on moving data from ZOS, and there's like kind of three stages. There's a pre-stage where you have the cataloging information, eligibility, that kind of maintenance item on what needs to be moved, when it needs to move, so on and so forth. And then you have the movement piece, which is in the middle. It's kind of dictated as the yellow here, and then you have a post-processing. After the move has happened, you update your catalog, so on and so forth. So if we look at what that looks like as far as the amount of resources that takes, the pre-post activity and the pre-activity and the post-activity all kind of remain the same regardless of the event, the size of the data set, or anything else. It's, you know, what it is. But the data movement, it can be huge, especially the larger your data sets, the longer processing time it takes, more resources that it takes to move that data. With transparent cloud tiering, what we do is we take out that yellow piece, or the majority of that yellow piece. So you still have to read it off a primary disk, but now the ZOS no longer has to do all that processing. So it kind of evens it out. So the larger the data set, it's all the same. It reduces the amount of resources in your ZOS, and matter of fact, kind of makes it this even line. So how much savings can you get? Again, depending on that data size. Some analysis that we've done on the upper chart shows on the left side an HSM 7 gig data set. And this is unofficial data, as far as, you know, this is just what we've observed in our testing. But this HSM 7 gig data set previously took 7.5 CPU seconds on an ML2 system, or using the ML2 method. And when we use TCT, that reduces all the way down to 0.02. So huge difference. Now, the right side is a DSS full volume dump using 64K cycle volumes and 9.5 CPU seconds, down to the same. Like I said, it kind of just evens out to this 0.02 no matter what we do. So you can see that no matter, you know, if you're already using really small or tiny data sets, you don't get quite as much savings. You still get a savings, but the larger the data sets, the more savings that you'll observe. The bottom kind of shows a tool that HSM has to, if you're curious, you're an HSM user, how much will CPU savings will I get? You can run this tool against your statistics that you get up into the host area, and it will spit out the information of how much CPU savings that you'll get based on your, you know, 1 week worth of data. And what we've seen is this kind of shows 46% savings on day 1, 78% savings on day 2, and so on and so forth. But we have a lot of customers that across the board show 90-some% CPU savings. I think the lowest I've seen was in the 30%. I don't think I've seen anybody any lower than that. So it's pretty substantial. And the chart on the lower right just kind of shows, you know, that growth, you know, the larger your data set or your track sizes, the more CPU savings that you get. Other benefits, as we know with HSM, there's a lot of reclaim activity that has to happen when you write those logical volumes to a system like the 7700. It has that logical volume can contain hundreds or thousands of data sets. And as those data sets change and expire, the volumes that you've written on the 7700, although it may expire in the host side of things, but that logical volume doesn't go away until you reclaim it. So we have reclaim cycles where once that tape hits, you know, a certain percentage, something that you've dictated, 20%, whatever it may be. Once it hits that percentage, then it has to be recalled back up into the ZOS system, and any active data written on it has to be rewritten to a new tape. That tape's filled up and then it's sent back down. So that all is part of this processing that the ZOS has to do, that consumes all of this, all of the bandwidth, you know, on your system. So with objects, we no longer have to do that. They are literally stored on your 7700 as objects. There's no reclaiming required. You know, once that the host expires that data, it is removed from the 7700. So removes that need to do the recycles. The other advantage is the parallel access to the object. So that's one of the items that tape is its serial access. So if you need 2 data sets off of that one tape, you can only recall them one at a time. So you have to do all these special things to make sure that your data sets are being spread out into tapes so that you hopefully don't have that problem, or you do have a lag time. With objects, there's no more problem with that serial access. So just kind of the evolution or the timeline of this feature. ZOS and DS8000 first introduced this feature in 2017. DS8000 on their simplex environment, and this the first host application to support this was HSM migration. In 2018, DS8000 made some major changes where now it supported basically all of their environments, including Metro Mirror, Global Mirror, and Metro Global Mirror, including Hyperswap. They also added support for 10 gig Ethernet, because all this data runs through Ethernet. And they added DS8000 encryption to a traditional cloud. Traditional cloud meaning your Amazon AWS, your IBM Cloud Object Store, so on. In 2019 was the first time 7700 supported DS8000 Object Store. So that's our original release of this product, of this feature. And with this feature, DS8000 is in charge of forking copies to two 7700s. In 2020, DS8000 introduced the object encryption and compression algorithm to the 7700. DFSMS, DSS introduced full volume dump support and also dataset backup support. And then this year, what we're working on right now is advanced object store. So this is going to be, instead of DS8000 regulating the copies, doing the fork copies, now the 7700 is going to take over that piece, and through policy management, it is going to support your duplication of your data, just like we do on logical volume systems. Also, it includes grid awareness, and we're going to talk all about these items in greater detail. DS8000 also comes out with the multi-cloud support, which we'll talk about in detail too. So just some key things about our previous release that are still pertinent and that we will be driving off of. This uses your existing cache. It uses your existing gridded Ethernet adapter. So you don't have to add any additional cache storage or anything like that. We utilize the same cache partitioning that we do today for if you have a physical tape or a cloud behind the 7700, we separate that data utilizing cache partitioning. We leverage cache partition for these objects and separate the data in that fashion. The other advantage here is that as you're growing your data center systems and you need to support additional items, this provides a route for your data to travel over your lower cost Ethernet and not through your higher cost fiber channel and FICON. So, you don't have to implement additional FICON through to get this. And in fact, it will reduce your FICON workload by utilizing your Ethernet as well as a way to transport that same data. So cost savings there, where you don't have to keep growing that more expensive network infrastructure. And again, I already talked about that in this release 5.0 that came out in 2019, DS8000 was the one pushing the synchronous copies to the two 7700s. And the other thing we continue to support, and that is we can have multiple DS8000s target a TS7700 grid, and that continues to happen as well. And these systems can be a standalone 7700 all the way up to an 8-way. However, a DS8000 can only target one or two of those 7700s in your grid, and that's where the advanced object policy management comes into play, because now the 7700 will be the one moving that data around. So if you need more than 2 copies, we can provide that to you. So logical cache partition, the only thing I'm going to really talk about in this is actually something that we came out with 5.0. We haven't talked much about, but it does come into play for the new functionality that we have. So as I said, we're using cache partitioning in the 7700 to divide or separate that data from your tape logic data. But inside that bucket of data, that object data that is showed here on the lower partition, is we do separate that data actually by what we call cloud name. Now, when you configure transparent cloud tiering, one of the things you have to do is go into DFSMS into their ISMF panel, and you will configure a cloud network connection construct. And that construct will have a name, and it will point to a DS8000 or set of DS8000s that's in a storage group. And from there, that cloud name is utilized in the DS8000 to configure to your cloud object stores, whether that be a 7700 or an Amazon or an IBM cause system. You will use that cloud name to configure with. And now with the 7700, you are going to use that same cloud name. You're going to add that to the 7700, and we're going to use that to drive policy to your 7700. And we'll get into that in detail. Now, the other thing, the advantage of doing this is that the 7700, even back during this time, we actually separate the cloud name internally into different buckets. It's kind of invisible to a user up until this release, but we had been doing that previously because that's the DS8000. When they come and configure to us, they have provided us with the cloud name. And internally, we're separating that out so that we can provide statistical information by the cloud name bucket. And this plays into policy management and understanding where your data is coming from and which DS8000 or which host plex it's coming from. So with this and the new support that DS8000 is providing, that is their multi-cloud support, these buckets become a little more important. So again, we'll diving deeper into that. Some host applications that we already support. I just want to mention the bottom one is what DFSMS HSM is working on right now. This is a statement of direction that they will support the full volume dump through HSM as well. So just an added one. You can look through these other ones we've supported for a while. So DS8000 multi-cloud. In August of this year, the DS8000 team has provided this support. So prior to this year's release, the DS8000 could only target 177 or one cloud storage from a DS8000. So you could configure only to one cloud. So if you configured it to IBM Cloud Object Store, that's the only cloud that you can target to. So all your data goes to that same system. With the August release of 9.2, they can now support up to 8 targets, simultaneous targets. So that could be, you could target one construct to a 7700 grid. You can target another one to an IBM Cloud Object Store. You can target a third one to an Amazon S3, or you can configure all 8 of them to one or the other using different containers. You can even configure all 8 of them to a single TS7700 grid or multiple TS7700 grids. And we'll again get into why you would want to do that because of the policy management. All right, so now let's get into, so we're kind of dubbed this feature Advanced Object Store. This is a feature that we're coming out this year, feature code 5283, and it will be coming out in our 8.52.200.x release to be determined. We also require DS8000 support for this, and they will be adding this to their 9.2.x release as well, coming out this later on. On the DS8000 side, so the DS8000 TS7700 team, we work side by side. In fact, we're in the same building in Tucson, Arizona. And actually the DFSMS team is in the same building as well. And matter of fact, DFSMS, I could, takes me 30 seconds to walk over to their side of the building. And DS8000's on the other side, takes me 2 minutes to get there. But so we all actually work in the same area. We talk to each other a lot of times, multiple times a day. We meet definitely once or twice a week, if not more. And so we definitely have a lot of synergy between these products and work very closely together. So DS8000, some of the changes that they had to do to support the new advanced object store is that we no longer need that forking. We no longer need DS8000 pushing data out to two 7700s as a synchronous write. Instead, they are still going to be targeting one or two 7700s, but they will be now load balancing between those two. So we have greater throughput now that we can use two 7700s as an avenue into your grid. And this definitely mimics how we do FICON today, right? Where your host can target two 7700s and load balance between them. Same thing here. So DS8000 will now load balance the workload coming from ZOS, targeting two 7700 clusters. And then those 7700 clusters will be in charge of replicating that data anywhere else in the grid if you need another copy. They've added robust retry mechanisms, so on and so forth, when working with these two 7700s. And also, when you think about a DS8000, they also have two KECs, and each one of those KECs are also load balancing. So you have actually two DS8, you have a DS8000 with two KECs now can load balance between two clusters in the grid. We have a mechanism of where we now have pools of connection. So in our prior release, really what the DS8000 was doing when they were talking to the 7700 is they open up a connection, they would go do a put, and then they close that connection. If they had to go read, they would do the same thing. So now we have a pool of connections, and we're leaving those connections open so that we can do multiple puts or multiple gets continuously, instead of having that overhead of opening and closing a connection every time you want to do one transaction. So we're adding some sophistication to that so that we can provide better performance. And then also they provide some link health information, which they never did before. So they are constantly monitoring the connections between the 7700 and the DS8000 and can post events of the issues that, if there are any. So on the 7700 end, so really the rest of this deck kind of talks about 7700 and this new feature. So this new support, all DS8000 enabled 7700s become now aware of these objects. And this means that we now house a database of these objects that we never did before. Before we were, other than in a cache capacity stance, that the 7700 was kind of oblivious to the single individual objects that it was holding. With this new release, we will be aware every 7700 that has this new feature code on it will be aware of each one of those objects. And this is key to the way we structure our grid support and how we, and it kind of mimics how we handle logical tape volume data as well. So what this means is that, for instance, in this image, we have DS8001 with the red arrows that are pointing to cluster A and B. And both of these, like I said, doing load balancing between these two clusters. So DS8001 writes the yellow object on cluster A, and through policy management, that yellow object can be replicated to cluster C and D as a synchronous copy or an asynchronous copy, depending on how you set up your policies. If, let's say now cluster A needs to come down for maintenance, So it's down now, and now the host says, hey, I need to recall, or I need to read the yellow object. DS8001 can still access that object through cluster B, even though cluster B doesn't have a copy of it. It is aware of the yellow object, and it knows where that yellow object exists. It knows it exists on A, C, and D, and it also knows that A is offline. So I'm going to go read it from either C or D, whichever one is the most optimal place to get it. So once, cluster A remains in maintenance, and now DS8001 writes a red object, and that red object shown here is replicated to C and D as well. When cluster A comes back online, it will be immediately told and now aware of the red object. So if cluster B needs to go down in the maintenance, then it can also access that red object even if it doesn't have a copy of it. And we talked already about bulk processing and meta, so I'm not going to get into that any further here. So additional key points, this is your FICON virtual volumes and your DS8000 objects coexisting in the same 7700. And I can't stress that enough, because one of the problems that we have today is there's so many different little appliances out there, and you have to maintain it. There's a lot of, you have space that takes up for that appliance and so on and so forth. So really what we wanted to do here was, we didn't want to provide another piece of hardware for you that you had to go and figure out what to do with. This is the same data that's already being stored in your 7700 as logical tape volume. So why not just store it as objects? So that's really what we're doing here. Is it's just using the same hardware you have on the floor without having to have a big, expensive additional piece of hardware and putting them in the same place. You already have security around that system. You already have it on the floor, etc. And secure data transfer is an item that we came out with for tape logical volumes in the 5.0 time period as well. Now that we're replicating objects between 7700s, that secure data transfer feature called feature code 5281 is also applies to the object data we will now be replicating. So if you already have 5281 and you have it turned on, this will automatically include your objects. We continue to have more than one DS8000 that can target a 7700. And in fact, that same DS8000 can now target the same or different 7700s. But you can utilize, a different cloud name to now direct data to the same 7700 for policy management. We can have a maximum of 256 object store connections allowed to that 7700. So if you have one DS8000 and it's using all 8 of those cloud network connection constructs to target one 7700, that's 8 of them right there, 8 of the 256. So just some quick requirements. This does require a 7770 VED with the new microcode level that we'll be coming out with later on. There is actually a new piece of hardware that you will need for this feature code. It is covered under feature code 8083. And what this does is that it requires 2 new SSDs to be installed into your Power 9 server on that 7770. And this is where the object store database is going to be housed. So we needed a larger piece of space, because with working with objects, we're going to be now working into the hundreds of millions of objects instead of just that 4 million logical volumes that we handled before. So it's going to be a much bigger database. We needed some more power. We needed some more room. So that's the reason for the 2 new SSDs. And the 7770s, we have 2 empty slots that we can put those in. So it's a pretty easy, quick installation. Your main feature is 5283, like I had said before, for this feature. On the DS8000 side, you're going to need the, if you're already utilizing the ZOS, the Z Synergy bundle, which you normally are if you're working with mainframe with the DS8000, you just need the Z Synergy bundle with the 9.2.x microcode, which will be coming out later this year as well. So you have to wait for that. And on the Z side, there's no real additional APARs that directly support this, although I know that they've had some additional performance improvements and stuff like that. So you want to just make sure that you have the newest versions at R3 and R4 with all the appropriate APARs. So, you know, just there might be some list out there. I don't have them listed here. Again, we still continue to support standalone all the way up to 8-way grid support. We do support objects on your disk-only systems, your tape systems, and also cloud attach with an RPQ. And the only reason for the RPQ is that when we go to release, we're not sure if we're going to be entirely done testing on a cloud storage attached system. We want some extra time for it. So we want to see how you're using your 77C and ensure that we've had at least an adequate testing on that. But we do plan on having that done early next year and to get that testing completed. You can have older 7700 models in the grid. So if you do have some older models and different code levels, they can be in the grid, but they just can't be DS8000 TCT targets. And if you are a customer that has feature code 5282, this is the one that we released in 5.0, then you will be required to do an MES upgrade to 5283 before you can start using 5283. And that's very important to know, because we won't support a mixture in an environment, and we want to actually push everyone to 5283. And in fact, after this release, we will no longer provide sales for 5282. It'll all be 5283. So we want to move all those customers to this new feature and only support the one. And that'll become, and that'll be coming out first half of next year to do that migration. All right, so setup. You know, first thing you will have to do on your 7700 side is, as I said, have that feature 8083 MES process done, which installs 2 new SSDs in your Power 9. You'll go through a very short 5283 MES process as well. And what that does basically is it will create, it will not only enable this feature on that TS7700, but also goes out and creates a object partition on your system. And that's the partition that will be putting all this object data into. You can go and resize that partition just like you would any other tape partition if you have tape or cloud partition. So you would just resize it at by default, we start out with 3 terabytes of space, and you want to increase that depending on how much object data you're going to be putting in there. And it works very similar to tape partition, where your resident only for your volumes, your tape logical volumes, comes from cache partition 0. So that's our main big storage device. And so as you're resizing your other partitions 1 through 7, and that includes your tape partitions, you are removing that from your cache partition 0, your resident partition, and moving it to these other partitions. So you have to have enough in your resident only partition to increase another partition on your system. So that all works the same as tape. So once that is done, the last thing to do is to enter DS8000 IP addresses into the 7700, and this provides a way to allow access into our system for those IP addresses. You know, allows it through our firewall. All right, so next thing we're going to do is create object policies. So this will be a new page found under the object icon. This is a new icon. I have a little orange arrow pointing to it. So when you install this feature, this icon will show up, and it'll have 2 choices underneath it that you can select. One of them is object policies. Here's an image that shows what the new page looks like. And here you will provide a policy name, whatever you want to make your policy name into. You can put a description. And then you're going to set some policy. And our first policy type that we'll be supporting in this release is replication, of course. So here you're going to select which clusters will get a copy of that data or not get a copy of that data, whether you support synchronous copies on that to those clusters or deferred copies. This works very similar to management class. So if you're a 7700 user and you've set your management class up, it's really the same thing. We decided we're not going to use the same management class. We wanted to separate that logical volume aspect from the object aspect so that we can grow the object piece, because otherwise it'll start getting pretty complex and filled up, and we wanted to simplify things. So this is only for objects, only for object replication. And the other nice thing about this page is it is a grid scope page. So if you're familiar with management class, for each cluster, you have to go log into each cluster, set up the management class for that cluster. And then, even if they're in the same grid, what this does is that you can set up all of your object replication policies from one cluster. You log into one cluster of a three-way, four-way grid, whatever, and you're going to set your policies for each one. And in here, I have three clusters. Elwood, one's called Elwood, that's cluster 0. The other one's just called cluster, and it's cluster 1. And then I have Kid Poker, which is cluster 5. By the way, these are my development machines. So I can set policies for all three of these clusters in this three-way grid, and how they will react if they are the target of the DS8000. So if I am Elwood and I get the put command for an object, then I'm going to do a deferred copy or a copy to myself, and then I'm going to do another deferred copy to cluster 1 and no copy to Kid Poker. If I am cluster 1 and that is my DS8000 target, I'm going to do a synchronous copy to myself and to Elwood, and no copy to Kid Poker. And Kid Poker in this case gets no copy. Why you would do that, I don't know. It's just an example. All right, so the second item under that object icon in navigation is simply called Object Store. In this page is where you're going to put that cloud name. Now, this is that cloud name that I talked about that you have set up under DFSMS as part of their cloud network connection construct name. And you have to add this to the 7700 prior to starting IO, because otherwise your IO will fail. The 7700 will go, ZOS through DS8000 will send us the cloud name for every put operation, and that tells us, and actually it's every put, get, and delete, and that basically tells us where that data is stored and for which cloud store that you are referring to. And when you add that cloud name to this panel, you are going to select a policy. So this is where we connect those cloud names to policy so that you can manage your data differently. So if you think about how logical volume data works today, where during a LUM processing, you can send down the 4 constructs, the storage class and the storage group and the management class and the data class into that LUM. And that is sent down to the 7700, and we utilize that to determine how to manage your data based on what you set for policy. This is the same concept, except for at a higher granularity, at a higher level, because one of the things, just speaking with ZOS and a lot of our customers, is that typically you are managing that data the same way. It's like a whole bunch of data and they all get managed the same way. So it's kind of repetitive to do it at a granularity, especially like at an object granularity where we're going to be looking at hundreds of millions of objects, right? They're all going to be handled very similarly. So instead of trying to be that granular, which would be difficult to even handle, we are utilizing that cloud name, that construct, the cloud name, as a way for you to decide how you want to manage that data. So this goes to that multi-cloud where now you can set up 4 different constructs on the ZOS and go into the 7700 or the DS8000 and configure each one of those cloud names or those cloud stores to the same 7700 as a way to drive different types of policy management. So as I stated before, if, in this example, we have policy name 1, policy name 2, maybe policy name 1 is all deferred copies to all clusters in the grid, and policy name 2 has synchronous copies to 2 of them. So you can utilize 2 different cloud names to drive 2 different types of policy management. And as we expand the types of policies that we'll cover under objects, kind of grows, and you might have different attention values, and maybe you want some to go to tape and some not, so on and so forth. So that will help drive future policy. Very similar, this is a grid scope page. So whatever you set up here gets replicated to all those other DS8000 enabled clusters. All right. So additional items, as I already stated, if you're using secure data transfer, or if you want objects be transferred between 2 clusters in the grid encrypted, then you would need the feature code and turned on. But the same thing is that if you are wanting secure data transfer between a DS8000 and a 7700, then you would just enable that encryption option on the DS8000, and then just ensure that you have the feature code 5281 on the 7700, and the DS8000 will discover that we can handle encrypted data, and it will start talking to us through OpenSSL using encryption. You just have to have that the feature on the machine that you're targeting. And then also, if you are changing certificates, the 7700 and the DS8000 both come with default certificates. And if you are going to provide your own trusted certificate, then you'll have to make sure that you change those certificates on both DS8000 and 7700 now if you're utilizing this. And there's more information about this that goes into detail in a red paper that we have for this feature. I'm not going to spend a lot of time on DS8000 setup. I just provided this here more for information. There's some white papers out there that talk about this. But basically, when you're on the DS8000, again, you have to configure to the 7700 by providing the IP addresses for that 7700. And then with multi-cloud, there's some additional steps that you need to do to configure the next cloud configuration, and then all the way up to the 8. Same thing with the host setup. I'm going to kind of breeze by this. There hasn't been any changes as far as setup goes. On the host side, there's some information here. We could spend a whole hour just talking about host setup, on the different host applications. So I'm not going to get into it in this session, but here's some information that will provide you. So just the main thing is that we'll need at least one cloud network connection construct to use TCT in the first place, and you might use multiple for the policy management. Okay, so this is kind of like a step through a little bit on kind of putting the pieces together. So down here in the lower right section is you've gone out to the 7700 and you created your object policies and you've set your replication. So here we have OBJ policy 1, 2, and 3, and each one of them has some sort of a copy mode where D means deferred, N means no copy, and S means synchronous copy. So we set up our policies on the cluster, and then step 2 is we set up our object store. So this is the object store 1, 2, and 3. And those are the cloud network construct names that came from ZOS that you will be putting into ZOS. We don't have to actually have that set up at this point, but you will have to set up before you start running IO. And each one of those is set to a different policy in this case, so that we can drive different types of replication. Step 3, this is now configuring the DS8000 to talk to 1 or 2 7700s. And I just put clusters 0 and 1 in here, but these would be IP addresses. So you would do your make cloud server command, and again, using the same cloud network connection construct name, object store 1, 2, and 3, pointing those to the IP addresses of cluster 0 and 1. And then the last step is you go into your ZOS and actually configure in their SMS panel the new constructs, object store 1, 2, and 3, and they point to the DS8000 IP addresses. So host points to DS8000, DS8000 points to the object store behind it. So when that data is transferred, when the host starts doing their jobs, they look and say, oh, that job is object store 1. I need to send it to this DS8000. That DS8000 says, oh, this is object store 1. I need to send it to object either cluster 0 or 1. I'm load balancing, so I'm going to pick one or the other depending on my load balancing algorithm. And then when that put comes into, let's say, cluster 0 in this case, cluster 0 says, oh, that's an object for object store 1, and I need to use policy 1 for that. So just basically a few words about containers. On the 7700, there's no way for a user to create a container. It is all created by the host application. And this goes for actually traditional object store behind the 7700 as well. Users don't create containers, the ZOS creates them. So they are in charge of creating and deleting the containers for each object store. Provided a little bit of information. This has actually been out for a little while. DSS, if you're using DSS to do your workload, there are also some existing commands using cloud utils. I think there's supposed to be an S actually after L. It's cloud utils, where you can list and delete containers as well. So users cannot modify, delete, or anything a container on the 7700. And objects, again, objects are created by ZOS, and 7700 does not provide any way to create, delete an object. And in fact, through host, objects are immutable. So hosts don't even modify. They're either created or they're deleted. There is a concept of being overwritten. That's considered a delete. And each object is going to be associated with the container that was created by the host. So all objects will be under some container, and they will also be under some cloud name. And again, that cloud name is important to 7700 so that we can manage that data the same way. So object copy processing. This works fairly similar to how we handle logical volume copies, where you do a put to a 7700. That 7700 will look at its policy. So if in this case, we're pointing to cluster 0, and cluster 0 goes, oh, that's, cloud name 1. I'm going to use, object policy, X. And that says I do deferred copies to all clusters in my grid, whatever it may be. And then the 7700 will push those copies, or actually pull those copies from each 7700. So the first thing it does is it educates each cluster in the grid about this object. So if I'm cluster 0, I go send out my information to cluster 1, 2, and 3. Regardless of whether they're getting a copy or not, each cluster will now know about that object. The cluster will also look at the policy that was sent to them by cluster 0. So I'm cluster 2, and I now know about this new object 1. And I know that the policy is DDDD. That means deferred to all clusters in the grid. I'm cluster 2, and I need a copy of that data. So what I will be doing is putting a copy of that object into my copy queue, my object copy queue on cluster 2, and cluster 3 and cluster 1 does the same thing. So now on cluster 2, I have this list of objects that are going into my copy queue. Now this is, again, very similar to the copy queue in logical volumes, except for it is a separate copy queue. We're going to have a totally separate queue for objects. And again, just working very similarly, I look at, what kind of copy it is. Is this a deferred copy, so on and so forth, and that tells me the priority of the copy. If this is a synchronous copy, then basically that cluster 0 will be forking the write of that copy simultaneously between, and I don't have it on this example here, but let's say I have an object 4 and it has a synchronous copy to 0 and 2. While we're writing to 0 is also forking that copy to 2 at the same time. So again, kind of similar to how we worked previously. And then, as I said before, if one of these clusters goes offline for maintenance or whatever, when it comes back online, it will immediately be aware of those objects. If it requires a copy, it will put it into its copy queue. If it was a synchronous copy that was supposed to be going to that cluster, we do enter, the grid enters into a sync deferred mode. Again, this is very similar if you use synchronous copies in 7700 before, this will be familiar. We'll enter a sync deferred mode, and the system will be considered quote unquote degraded. It just means that we understand that we have only one copy of the synchronous copy. Those copies that are sync deferred are prioritized over all other copies so that we can get those copies done first. So some considerations, this is always a consideration, even in a 7700 grid, when you have clusters that are located some length away. We have customers that have systems in the US and in the UK, very long line, and IP extenders are really just a requirement to eliminate that latency. And so basically this chart just kind of talks about, what it looks like without the IP extensions and what it looks like, with them. So it's extremely important. Now this also applies to those DS8000s that you're going to be targeting 7700s to. So if you have a two-way cluster, one in the US and one in the UK, and you have a DS8000 that will be forking to both of those, you have to take that consideration as well on the long distance one. It's whether you will require an IP extender or not. So I'm going to kind of skip a few things here and just hit some highlights since we only have a few minutes. We are introducing some library request commands. The OCopy summary really is the main one I want to talk about here. This will provide you a quick overview of your copy queue, your object copy queue, which will show you what the copy queue looks like on each one of your clusters, and by count and by size. So just keep in mind, new library request command on that. This one as well, this actually was introduced in 5.0, very important one to know about though. So this provides a way for you to set alerts on your object cache partition. So there's a low alert and a high alert. So when the low alert goes off, it basically says, hey, you're getting kind of low on your cache partition space. So you should probably go do something about that. And your high alert is kind of like a panic mode. You're almost out, you want to set that to where you better change it now. Otherwise you're going to, run out of space. So this is where you would want to go back onto the 7700 MI cache partition page and increase or decrease that. So we're not going to get to all of these, but some BVIR information to get some statistical or other information. There's some in here you can go look through. I guess the only one I'm going to probably go look at real quick is the historical summary, because we have so much stuff in there. But just keep in mind that we do have object status information that you can get, the copy audit information, or just if you want a dump of your copy queue on a cluster. That's all information that you can look in here to get that information. So I just wanted to show this page real quick. These are all the statistics that we are now going to be adding in here. And this goes back to separating that bucket into those cloud names. And as you can see, the ones with the green kind of box are all statistics by those cloud names. The only one that's not is just kind of the overall general statistics, where you get the overall counts on certain things. One of these items are, the green items are now statistics by each one of those cloud names, which can be indicative of a DS8000, or maybe just a bucket of data that you want to keep track of. So another thought on when you're trying to decide, how many cloud names to your advantage. And last but not least, dual control. So we talked about the object store panel and the object policy panel. If you are using the dual control feature that we introduced in 5.0, which provides a two-person approval to get to do any type of transaction on the MI that's considered extremely important, these new knobs on modifying or deleting object policies and object stores are covered under dual control. So somebody can't go in there and just remove your or change your policy without a second person approving it. So at that, I am done, and we only have a few minutes. So I don't know, Nigel, if we have any questions.
Yes, we do have some questions. Okay, thanks for the advert about the session feedback. That saves me saying it. We've probably got a few minutes to handle the questions, so I'll go through them in order. And before I do that, in fact, I'll let everybody unmute themselves if they have follow-up questions. So the first question was from Sean Catlow. Are there any plans to support anything other than S3 storage, for example, Azure and iStuck or Google Cloud as another option?
Yeah, that's not an easy answer. Maybe. And a lot of that is driven by customer feedback. If we have enough customer feedback that says, I need, Azure or whatever, Google Cloud or whatever it may be, then we will look into it. And we have actually had a few requests, and the best thing to do is we've asked customers, put in an RFE and let's get some votes. And if we get enough votes, then we'll more than likely try to support it.
And I guess the difference there is the sort of get and put semantics differing between the different cloud vendors.
Yeah.
Yeah. Okay. Sean, I hope that answers your question. The next one was from Shlomo, and we might need your help with this one, Shlomo. The question is, are TS7700 T and C offload to cloud and to library from the same cluster? Not entirely sure I understand the question.
If the question is whether those objects can go to tape or cloud behind the 7700, the answer is no at this time.
Okay, so Shlomo, if that's not represented your question accurately, then unmute yourself and I'm sure we can sort it out. The next question was from Patrick Loftus, which you said you answered in a later slide, but I'll repeat it anyway. Is it easy and non-disruptive to resize the partitions? For example, could you decrease the storage allocated to the cloud partition in order to reassign to the virtual tape partition, and I guess vice versa?
Yes, it is disruptive. In fact, if you have tape or cloud today behind the 7700, it is pretty instant. When you do that. With objects, it actually takes about 2 minutes because, again, to separate that data out into those smaller buckets, those cloud name buckets, we do have some partitioning, some additional partition we do internally on the system. So it takes about 2 minutes, but yes, it's entirely disruptive, doesn't cause any issues on that aspect.
Sorry, Laurie, you said disruptive. Did you mean non-disruptive? Because I mean,
yeah, it is non-disruptive. Is that what he said?
yeah.
It is not disruptive.
Okay, that's a better answer. Thanks. Okay, are there any other questions? I think Shlomo's happy. As I've mentioned, if you want to unmute yourself and ask a question by old-fashioned traditional voice, then you can do so.
Yeah, and I do have my email address on here too. If you have any questions later on, feel free to reach out to me.
Okay, I'm guessing from the chat that everybody has asked the questions they wanted to and got the answers. So with that, first of all, Laurie, thank you very much indeed for this session. It sort of brings together a lot of threads, and it's nice to see some serious detail in the presentation, so that it makes it clear exactly what you have to do to implement cloud storage on the TS7700. So that was great. Thank you very much. If there are no last second questions, then please remember to do your feedback. And thank you very much, everybody, for attending. And thank you very much, Laurie, for presenting. And
yeah,
with
thank
that,
you.
I'll close the call. Thank you.